Like before, they could give you two inequalities, and they want you to find the set of values that satisfy both of these by wanting to combine the set of solutions together. So for example, for the question, find the set of values that satisfy both. Remember, both is the indication of the and therefore that shows that you need to find the set of values that satisfy both of them at the same time. So find the set of values that satisfy both minus x squared plus 5x minus 6 is less than or equal to 0, and 2x minus 3 is less than 11. Really quick, it doesn't specifically say this on the specification, but like simultaneous equations, I've never seen them ask a question where they want you to find the set of values that satisfy two quadratics. If they're going to ask a quadratic, they're going to give you one of them will be a quadratic and one of them will be a linear. So don't stress about two quadratics. So the approach is the same. You need to solve them individually first. So let's do the second one first because that looks a bit easier. 2x minus 3 is less than 11. We bring the minus 3 onto the other side to get 2x is less than 14. Divide everything by 2 to get x is less than 7. And then for the first inequality, we don't need to rearrange it because it's already in the form we want. We need to make the inequality sign equal, so minus x squared plus 5x minus 6 is equal to 0. And then we find the roots. We can do this by factorization or by using a calculator. And we will find the roots to be 3 and 2, the values for this equation. Then we sketch a quick graph. Remember, it's going to be a negative parabola because the coefficient of x squared is minus 1. So I'm going to kind of draw my quadratic like this. The quality of the sketch isn't too important. It's more to help you, so the scaling doesn't matter, or the quality, etc. So we compare this to the original inequality, which is here, which is minus x squared plus 5x minus 6 is less than or equal to 2. It's less than or equal to 0. So it's less than or equal to 0, so therefore it's below the x-axis, so therefore it's going to be these values here, because these are the negative ones and these are ones that are less than 0. And then using the graph, you can hopefully see that the solutions will be x when x is less than or equal to 2, because it goes in this direction like that. Remember, it's going to have the equal sign because the inequality here also has the equal sign. Or when x is greater than or equal to 3, because it goes in this direction like here. Of course, you could also put this into the calculator, this inequality here, in order to check your answer to make sure you got it right. But remember, you need to show the method, so don't just use the calculator. Now we need to combine our solutions together to make one set of values. Now this is a different approach because of the OR. We basically need to do this twice. Once when x is less than 7 and for x is less than or equal to 2, and once when x is less than 7 and when x is bigger than or equal to 3. If we try and do it all in once, it won't work, it will go really wrong, so we need to do it separately. So let's do the first one when x is less than 7 and when x is less than or equal to 2. This is quite easy to see that the inequality signs are the right way, and 2 is less than 7, so that will just simplify to x is less than or equal to 2, obviously. And then for the second one, x is less than 7 and x is bigger than or equal to 3. We can write these in the same direction to get x is less than 7 and x is bigger than or equal to 3, so we can write that as x is bigger than or equal to 3, and we can see that we can merge that to get that x is bigger than or equal to 3 but is less than 7. And these are our solutions. X when x is less than or equal to 2, or when x is bigger than 3 but is less than 7. We can, if it asks for set notation, you can write that as x is a solution when x is less than or equal to 2, close bracket, or, remember that's the U symbol, open bracket, x is a solution when x is bigger than or equal to 3, but is less than 7. And those are your solutions. One in the normal terms, and that is it in set notation. Okay, so finally, there's a special example that they could throw at you that you need to approach in a different way. So try and remember it, and I'll show you it now. So the setup will be the same. Find the set of values that satisfy, and it could be 1 over x is greater than minus 2. Now at first this doesn't look too bad because you could just times everything by x to get that 1 is greater than minus 2x, and then just solve the inequality by making x a subject, and it doesn't look too bad. However, when you do it this way, you're making a massive assumption, and that is x is positive, because you're not flipping the sign. So is x positive? And when you look at the question, well, x could be positive, but x could also be negative. And if x is negative and you times everything by x, the two numbers will be the same. But as you're timesing by a negative number, you have to flip the sign. And obviously these are going to give two massively different answers when you solve them. So you need to know whether x is positive or x is negative, so you know whether to flip the sign or not. So how can you tell whether x is positive or x is negative? You can't. There is no possible way in order to tell in this question whether x will be positive or x will be negative. So this whole method completely falls apart of timesing it by x, and if you do it this way, it's completely wrong and you'll get 0 marks in the exam. This is, by the way, the only time they will ask you in an inequalities question to times by x or an unknown variable, and therefore you don't know it could be positive or negative. But this is a problem because this looks like quite a big problem, because as we cannot tell the difference, we don't know how to flip the sign or not. Well, luckily there's another way that we can do this, which completely bypasses this whole positive negative thing, and instead of timesing by x, we times by x squared, because x squared cannot be a negative number, because there is no square negative numbers. X squared will always be a positive number. Therefore, you don't need to worry about flipping the sign or not, because you know that you won't need to flip the sign because x squared is positive. So if you times everything by x squared, you'll get that 1 over x times x squared is x, and that is bigger, remember you don't need to flip the sign, you know that you don't need to, is bigger than minus 2x squared, because minus 2 times x squared is minus 2x squared. And then this is a quadratic inequality, which we've talked about how to solve before. So first of all, we need to get it in the form ax squared plus bx plus c, and then 0 on the other side. So we can do that by doing 2x squared plus x is bigger than 0, where the c here is 0. Then we need to replace the inequality sign with an equals to make it into the ax squared plus bx plus c equals 0 form. Again, c is 0, but that doesn't matter because it's still in the right form. And then we need to find the roots. Now you could use a calculator, but there's a quicker way to do this in my opinion, is if you just factorise it really quickly, you'll be able to see that the roots are 0 and minus a half. Now we need to draw a graph. Now we know it's a positive parabola because the coefficient of x squared is a positive number, and we know the roots are 0 and minus a half, so we can draw the graph looking something like this. Once again, accuracy isn't too important. This is more just to help you. Now you need to compare this to the inequality that you made here, over here. So 2x squared plus x is bigger than 0. So you need to find the set of values that make the quadratic bigger than 0. And if you think about this and look at the graph, you will find that these values are when x is less than minus a half, or when x is greater than 0. And these are the two sets of values that make the quadratic bigger than 0. So this is the solution to the question. X is less than minus a half, or x is greater than a half. You could, if it asks you to write this in set notation as well, you would do that by doing open bracket. X is a solution when x is less than minus a half, close bracket, or with the U sign, open bracket, x is a solution when x is greater than 0, close bracket. Okay, so here's a question on quadratic inequalities, so pause the video, have a go, and I'll go through the answer in about 5 seconds. Okay, so for part A, this is just a linear inequality. 3x minus 7 is greater than 3 minus x. So we bring the x's onto one side to make 4x minus 7 is greater than 3. And then we bring the minus 7 onto the other side to do 4x is greater than 10. And then we divide everything by 4 to get x is greater than 10 over 4, which is equal to 5 over 2. So that's the answer. For the second one, we're going to do it up here. This is a quadratic. So the first thing we need to do is get it in the form ax squared plus bx plus c. So the way we do that is bring the first 6 on the other side to get x squared minus 9x minus 36 is less than or equal to 0. Then we replace the inequality sign with the equal signs to do x squared minus 9x minus 36 is equal to 0. Then we find the roots. I just put this into a calculator and I found the roots to be minus 3 and 12. And then you draw a graph. So it's going to be a positive parabola because the coefficient of x squared is just 1. And we know the roots are minus 3 and 12, so the quadratic is probably going to look something like this. And remember that we need to find the points where x squared minus 9x minus 36 is less than or equal to 0. So it's going to be these values here when it's less than it's less than 0. This is minus 3 and this is 12 because this is the roots, and therefore if you look at this you can find that these set of values is when x is bigger than or equal to minus 3. Remember, it's going to be equal because as well because we've got the equal part here as well for the inequality, but x has to be less than or equal to 12 too, and this is the solution for B. For C, this is both and, so you know that you need to find the set of values for which both of them are going to be true at the same time, simultaneously, if you will. So the way you do this is you are just going to write them all out at once. There's no or, remember, so you don't need to worry about that. There's no or for this part here, so you don't need to worry about that. So I'm just going to do it by my methods, where we write them all like that, and then we write them all with x in the middle, and then we write them all with the inequalities going in the same way. So the top one's fine, but the bottom one I'm going to change the direction. So x is greater than 5 over 2, so I'm going to write that as x is greater than 5 over 2 in this way. And if we merge these together, 5 over 2 is greater than minus 3, so if we merge these together we're going to get that x has to be greater but not equal to 5 over 2, but has to be less than or equal to 12. And this is the answer to C. Just bear in mind, this question doesn't actually ask for set notation, so you don't need to do it.